But it's just the three methods that we have been practicing all together at once. And there's one small detail is that with the three different methods, you might recall the questions are written three different ways. So with the graphing, they're both y equals. With the substitution, one of them was y equals. And elimination, neither are y equals. They both had x and y on the left. So if you just have the problem written one way, that means two of them you're going to have to rewrite it in some way for it to work. And that was the one thing that was a little different on here, is that you had to rewrite the question. Other than that, it was the same thing. So if we take a look at, let's say, the graphing here, one of them was already y equals. So we just had to go to this one right here, go to -2, and then go up 4/1, right? And you had your graph pretty quickly. However, the next one, this one was not y equals, so you had to do a little bit of work. So, but it's the same that you've always done. It's going to be equal to y. So you subtract the 4x and divide it by the 2. So hopefully, if you had difficulties, you looked at it as a way of, I forgot how to do that part, not as opposed to, we've never done this before, I don't know what's going on. Because it is all review. So this one starts with +4, 1, 2, 4, and then down 2/1, and then you can see right there, that's where the intersection takes place. So your answer, we know, should be where they intersect, which is 1, 2. Now, without saying anything, what should the answer be for these? Without doing any of these work on it. What should the answer be for substitution? What should the answer be for elimination? Yeah, 1, 2. So it's kind of as long as you do the first part correct, you know the answers for the other ones. It's just a matter of showing the work and doing it correctly. Because we're solving one question, they're all the same, so obviously you have to get the same answer. Now with substitution, this is already set up for you. Right? We have a y right here. We got y equal to 4x minus 2. This is what we did right after spring break. So 4x plus 2, and then in parentheses, we put, instead of the y, we substituted out the y for 4x minus 2. And then we had an equation to solve. Now, so when we solve this, we expect to get the x equals 1, because we know the answer is 1. So go through the steps here. Bring down everything else. 4x and 8x is 12x. Add 4 to both sides. I'm going to skip the algebra here. But add 4 to both sides, so you get 4 plus 8, which is 12. Divide both sides by 12, and we get x equals 1. So just as we suspected, we got x equals 1. And then you can plug it back in to here. And you get 4 minus 2, which is 2. Again, no surprise, we got an answer of 2, so it matches. So far, when we graph, we just had to do 1 y equals to get mx plus b, the slope and the y-intercept. The substitution, we didn't have to change it at all, is already set up. The substitution you use when you have a y equals already. If they're both y equals, you can do it as well. And then elimination, not exactly set up. We're used to having elimination look like this, where you have 4x, 2y, variables on the left, and then there's equal to the number on the right. This is really close. It has, one variable on the left and the numbers on the right, but this x is on the wrong side. So if we just subtract 4x on both sides, right, this stays the same. Now this will become negative 4x, which is good because it eliminates positive 4x. And then we have plus y equals negative 2. So now this is what all your elimination problems look like. So it's just one little step away to get there. So we have elimination of the x's. We have 2y plus 1y, which is 3y, which equals 6. And if we divide both sides by 3, you get y equals 2, which is no surprise. We already knew the answer should come out to 2 because of the graphing method and substitution got the same thing. And then likewise, plug it back in, and you can solve for x. So if I plug in the top, I'll have 4x plus 2y, 2, equals 8. That's 4 plus 4 equals 8, which means 4 times something equals 4. Divide both sides by 4, which equals 1. So all three methods got the same exact answer. So hopefully that answers that question, and just structurally, how should the whole thing look? I want to show you something visually now. Okay, just watch here for a second. All right. So if we take those two equations, what are they again? Let's see, 4x plus 2y equals 8. So we got 4x plus 2y equals 8. So that's one of them. And then the other one was y equals, what was it, 2x. Y equals 4x minus 2. We can see the answer is 1, 2 where they intersect, right? So the answer, the big idea here, the answer is where they intersect. Question though, what is the answer in this case, if the answer is where they intersect? What would the answer be here for this system? Right? So if they intersect, 1, 2 is the answer. If they don't intersect, what would we say the answer is for here? So this is what happens when you have a no solution. Okay? This is what no solution looks like. If the answer is where they intersect and they do not intersect, there is no solution at all. Okay? And likewise, what if we had, let's take that one off. What if I had negative 4x plus y equals 5? I'll make this one dotted. This one red. What is the solution for these two equations? You see they intersect everywhere, right? Look how many answers there are. Look how many points they intersect at. They intersect here, here. Every one of these little dots is an answer because that's where the two lines intersect. So how would we call, what would we say for this if we're trying to explain in a short phrase? Yeah, you could say all solutions or infinite solutions. So I want to let you know that at the end of this assignment on 26, that there are some no solutions that look like this where they don't intersect, so you're not going to get an answer when you do substitution or the elimination method. And there's also answers like this where when you graph them, they're actually the same exact line, and that's what an infinite solutions looks like. Okay? And then after you see the graph, you'll kind of know what the answer is, and then when you get to the elimination substitution method, you'll see that the variables disappear and there's no variables to solve for. Okay? So just know that's coming up as well. All right. Any other general questions from here? Any specific problem you want me to look at and the method? Or just need more time to work right now? Just to work. Okay. And close to the end of the period, I'm going to go over the next thing. If everybody's finishing, if not, we'll just take the period to finish this up. Okay. All right. Go to work, and I'll be around to help out.